All right, hey, is everybody ready for today? We're still going to make this a great day of learning. I'm going to be teaching you guys lesson 2.3, getting started with what's called discontinuities. You actually will take part in a little post-it note activity. Without the post-it notes, though, you'll be doing that online. Get ready to take some notes, have some earbuds in that you can listen to the video. That would be ideal. And I'll tell you what, even before we start the lesson, I'm going to be showing you guys a problem in your assignment. I'm going to help you start a problem in your assignment. So get a book, get a book right now, open up to page 72. I'm going to help you get started with number 49. Do you realize what sort of the objective is? We're trying to draw something. The thing that the first time you do one of these, the kids often ask, so how many drawings am I creating? Well, the answer is one. But it's going to have all of this stuff. Okay, so I want to try to help you to make this connection. Okay, so we got these limit statements. Now, the first one, you don't necessarily have to write it down, but the first one does say the limit as x approaches 1 is equal to 2. Now, what you need to be able to do with a statement like that, like I was trying to get you to do yesterday with the chart activity. By the way, nice job with the chart activity. I always like giving you some bonus points. I more like seeing you guys figure this stuff out. So this actually would have been in your first category. I remember Bryce was writing some stuff down. This is kind of like a good old limit, back when it was just the intended height. So we have a graph that has an intended height of 2 at x equals 1. How do you sketch that? Okay, I don't think you'll be too surprised when I show you that you're simply going to have a y value of 2 when you're getting close to an x value of 1. And I'm just kind of putting these little squiggles beside this because you need to start to create a graph. Okay, so those little squiggles are kind of saying, okay, there's going to be some kind of graph that's around that limit. Now, if you're already saying, why'd you make it a hole? How do you know it's a hole? I don't know. Okay, hold that thought. I don't know if it's a hole. Who knows? Maybe there'll be something that makes me fill that in. Okay, and by the way, if I don't end up filling it in, it's still right. Okay, so I'm just kind of keeping that as a thought. Another pair of limit statements. They're in your book, but sometimes, you see them up here also. Again, something honestly off of your chart, which you guys eventually got in the correct column. As x approaches 5, or from the left or the right, the limit is infinity. Okay, that's always a vertical asymptote. That's always a vertical asymptote. Now, right now, as far as this graph goes, I could mark 5 and I could put a vertical asymptote there because it's going to be true. But as you dig a little deeper into what the book gave you, we have like a left and right limit. So what we can do is be specific. Since it says that it's going to infinity, we have to imply that that's positive infinity. I kind of wish they would have put a positive on the infinity, but since it is infinity, it's positive, so it goes up. It goes up on the left. So now I can start to kind of connect the dots a little bit more. From the left, I can make it go up. See, we can say the same thing on the right. It goes up. Now, again, you have to get a graph. So I need something that I can draw. And again, my little squiggle is to kind of denote that I don't know exactly what the shape is, but I know that there's an asymptote and it goes up on both sides. Do you have any questions so far? Are you starting to get a feel for how you do a problem like 49? Okay, definitely something you will see repeated on a test, even on a quiz and a test. Because what this does, it shows that you can interpret these limit statements. Okay, so I guess the next one I'm picking out here is the one where it says x approaches infinity is equal to -1. Okay, again, something off your chart. Sometimes kids say, should I memorize that chart? You need to understand that chart. You need to be able to interpret it. I don't know if I would memorize, but you should interpret that if x is going to infinity and our value is -1, that means I'm getting closer and closer to a horizontal asymptote. And again, there's a horizontal asymptote at -1 since I'm going out to infinity and getting closer to that value. Again, the reason I'm going over this is to help you guys realize that you just need to connect the dots. So I connected the dot, and we have a little snake. Looks like it's hanging out of a tree, but it's getting closer to that horizontal asymptote. Maybe you feel like you can draw this. I'm moving on to the next limit. It's okay to look back at the chart. That's why we made it. But you want to start to be able to say, okay, this is always a vertical asymptote. We even have some descriptions about positive and negative infinity from the right and from the left. So the little plus sign to the right, the negative infinity says it's going to go down, and then the little negative sign is from the left, and the positive infinity says it's going to go up. By the way I'm kind of sketching this would be completely suitable for an assignment where you guys could do the same thing. I mean, it doesn't have to be like to scale. It doesn't have to be on graph paper. It just needs to show the important features, Is there anything that's going on here that you're wondering, why did you draw it like that? Okay, because there's, I think, 2 more statements. I mean, the author just kind of went berserk here. So we have another limit statement, which is another horizontal asymptote. So again, x goes to negative infinity, means that we're going over here to the left side to get a horizontal asymptote. Horizontal and vertical asymptotes are usually denoted with dashed lines. So dashing the lines is good protocol. Oh, I guess that was the last statement. Okay, so you have all those statements. Notice that I kind of pieced it together into one function. It's one function, even though it's all broken up with different features. And by the way, this hole that's in the graph, there's nothing that said that it had to be a hole. What that means is that I could have filled it in. Just again, to be clear, it doesn't matter as long as the limit exists. In other words, as long as the left and the right, as long as you arrive at the diner, okay, then it's correct. What we're going to do today, as we get into this next section, is that we're going to figure out how limits can be used to describe what's called a discontinuity. How can limits be used to describe a discontinuity? So we're not going to learn like a new limit. Okay, the truth is we've learned the limits. You made the chart, but we're going to figure out how limits can describe a discontinuity. And a discontinuity, of course, is a place where you have some type of breakage in your graph. Now, here's kind of the deal. Let me flip to this and let me show you this, and we'll get you a second to get your thoughts together. We've got this graph. It's full of discontinuities. And by the way, probably going to want to sketch it, and I'll give you some time to do that. But we got this graph. It's got some discontinuities. What I'm going to challenge you to do is to try to use limit notation. Okay, that means you're going to write statements on those Post-it notes. So you're going to write limit statements and try to describe what's happening at each of these x values. Now, I'll kind of just give you a little bit of a hint here. You don't have to worry about figuring out something new. I know I used the word discontinuity, but you don't have to like figure out, okay, so what do I do with that? You just need to write some limit statements for each of these x values. And then what I'm going to show you is how those statements you write help us understand discontinuities.